Welcome to the deep dive. Today we're looking at something really fascinating and honestly pretty intense, what it actually takes to survive on Mars. You might think of Mars as, humanity's next big step, our grand adventure. But the material we've gone through for this deep dive, it paints a very, very different picture, much harsher. We got hold of some incredible sources, including this really detailed look at a hypothetical mission, setting up a base there. So our mission today is to unpack the really crucial stuff about what life on the red planet would genuinely be like. We want to reveal the surprising facts, the challenges you might not expect, and what survival even means in that kind of place.
Exactly. It's about separating the sci-fi dream from the pretty stark reality. What's really striking in the material is the sheer ingenuity needed and, frankly, the extreme measures you'd have to take just to stay alive. We'll walk through the daily dangers, the engineering marvels involved, and, yeah, even some unexpected things like what Mars actually smells like.
Okay, let's dig into that. So first off, Mars looks amazing in pictures.
Right.
Stunning. But it's just fundamentally not welcoming. We're talking about some serious temperature swings. Like daytime high might be a balmy 20 Celsius.
It sounds almost pleasant.
Right. But then at night, it plunges down to minus 73 Celsius.
Minus 73. That's incredibly cold. Frostbite in seconds, hypothermia in minutes, basically.
Yeah.
And if you connect that to the bigger picture, survival there isn't about being comfortable at all. It's just constant vigilant protection, just staying alive. And it's not just the temperature. The atmosphere is, it's barely there.
Right.
Mostly carbon dioxide, hardly any oxygen. You just can't breathe it. It's effectively a vacuum, really. Step outside without protection and, it's instant.
And then there's the radiation, the low pressure. It's a whole list of things.
A very long list.
And, okay, you mentioned the smell. The source material actually describes the smell of Mars. What did it say?
Apparently, it's like rust and gunpowder.
Rust and gunpowder, wow.
Yeah. Not exactly roses, is it? It kind of sets the tone immediately. This is not Earth.
Definitely not. Okay, so you can't breathe. You can't stay warm easily. You absolutely need a habitat. It's priority number one. This hypothetical mission we looked at, it describes setting up a base. And it takes, about 3 months just to assemble a simple structure. And that's using materials brought from Earth.
3 months, yeah. And that raises the question, what kind of structure does it need to be? It can't just be any old building. It has to be absolutely airtight, completely sealed, and heavily insulated. Not just for the cold, but also shielding people inside from, all that radiation we mentioned. And the dust storms, too.
The dust storms, yeah. We'll get to those.
And crucially, it needs its own life support. A self-sustaining system managing air, water, waste, everything internally.
Powered by solar panels, mostly.
Primarily solar, yes. Which leads to another problem when you think about those dust storms you mentioned. They can block out the sun for days, weeks even.
That's a really good point. So you'd need serious battery backup, I guess. Energy storage would be critical.
Absolutely critical. Constant battle, like you said.
Okay, let's talk resources. Maybe the most critical one. Water. The source material really highlights some extreme measures for getting it and reusing it. Can you walk us through that?
Yeah, this is where it gets really eye-opening. So you could technically try to extract water ice from the Martian soil or maybe from the thin atmosphere. But the character in our source, this guy Chase, he finds that just too difficult. Too much energy, too much time involved for the return.
Okay, so what does he do instead?
Instead, the material really hammers home this point about closed-loop systems. Absolute necessity. He recycles water from bodily fluids.
It's sweat and pee.
Sweat and urine, yeah. It sounds unpleasant, but on Mars, every single drop counts. Every resource is finite. Every waste product has to be looked at as a potential resource for something else. It forces this complete mental shift, away from abundance towards extreme circularity.
It really is a stark reminder, isn't it? That no matter how advanced our tech gets, survival still comes down to these really fundamental, sometimes uncomfortable biological realities.
Absolutely.
Now, food. The source describes Chase's greenhouse, calls it a Michelin star greenhouse, rated out of this world. Sounds impressive, pressurized, kept at a cozy 16 Celsius. But then it says he had to build it unattached to his main living quarters.
Right.
Meaning he has to actually go outside, put on a suit, every time he wants to check on his plants. That sounds incredibly risky and inefficient. Why?
That's a really key point the source makes. It highlights these constant trade-offs, the daily challenges that go way beyond just basic needs. Even something that sounds simple, like checking your crops, becomes this whole complex engineering problem. It requires a full EVA going outside in a suit, exposing yourself to all those risks.
Right.
So why do it that way? Well, it probably speaks to the isolation of different modules for safety. You don't want a potential problem in the greenhouse like a breach or contamination to compromise your main living space. It's about containing risk.
Ah, I see. Compartmentalization. Makes sense, even if it adds hassle.
Exactly. Hassle and risk every single time.
And the food itself isn't exactly gourmet dining, is it? It's mostly potatoes. Taters, as he calls them. Not his first choice, apparently.
No. Potatoes are hearty, relatively easy to grow, high in calories. Practicality wins.
And the fertilizer.
Yeah.
Okay, brace yourselves for this one. It's human waste.
Yep. Because, as the source puts it, Martian soil is, well, literally garbage for growing things.
Yeah.
Figuratively speaking, of course. It lacks the organic nutrients.
So you have to make your own fertilizer.
You have to make your own soil, essentially. Using waste, it apparently makes the greenhouse smell pretty bad.
I can only imagine.
But, as the source character quips, still not as bad as Uranus.
Okay. So even with this carefully built compartmentalized base, dangers are everywhere. You mentioned dust storms earlier. The source describes them traveling at around 100 kilometers per hour, lasting for days.
Yeah, and strong enough, it says, to potentially slice right through a spacesuit if you're caught out in blowing sand and debris.
That's terrifying. So it's not just inconvenience like visibility issues. It's a direct physical threat.
Direct threat to life and equipment, absolutely. And that's not the only external threat. Another big one detailed in the source. Micrometeorites.
Tiny space rocks?
Tiny, but moving incredibly fast.
Mm.
The source describes the base's sensors detecting one, heading straight for the habitat, with a calculated probability of impact, 87.42%.
Wow, that's specific. That's not theoretical anymore. That's incoming.
Exactly. An immediate, quantified danger they had to react to.
And did it hit?
It did. It breached the habitat wall, and worse, fragments damaged Chase's helmet while he was inside.
Oh no, his helmet. Inside the base.
Yeah. And the description of his reaction, it's all about quick thinking. He had to improvise a patch, basically using tape, because, of course, his spare helmet was back in another part of the habitat.
Of course it was. Murphy's Law on Mars. It just paints this picture of constant improvisation, doesn't it? Really high stakes, things going wrong unexpectedly.
All the time. Constant vigilance, constant problem solving.
So, okay, let's picture this scenario the source lays out. It's pretty dramatic. A dust storm is raging outside. Chase's helmet is damaged, maybe leaking slightly from that micrometeorite incident. And his main living quarters are just 5 seconds away, 5-second walk across the surface. And he makes this desperate choice. He considers making that dash without his helmet.
His AI companion, Rico, strongly advises against it, like Danger Will Robinson levels of warning.
Yeah.
And what this situation really drives home is how, in that kind of extreme environment, even a tiny miscalculation, a split-second decision, can just cascade into total disaster.
So the big question, what actually happens in those 5 seconds without protection on Mars? What would kill you first?
You might think it's the cold, right? That minus 73 Celsius, or maybe suffocation from the lack of oxygen.
Yeah, those seem like the obvious candidates.
But the source points to something else, something faster.
Yeah.
The immediate killer isn't the cold or lack of air. It's the atmospheric pressure, or rather, the lack of it.
The vacuum.
Essentially, yes. The pressure outside is so low compared to the pressure inside your body, inside your lungs. The effect is almost instantaneous and catastrophic. Explosive decompression, basically. Your lungs would rupture. The liquids in your body would effectively boil.
Wow. So those 5 seconds, it's not about holding your breath or toughing out the cold. It's just game over instantly because of the pressure difference.
Instantly. It completely changes how you have to think about survival time. It's zero.
So what does all this tell us? What's the takeaway for you listening?
I think it means that even the absolute briefest exposure to the raw Martian environment is fatal, catastrophic. This deep dive, looking closely at this source material, it makes it crystal clear that surviving on Mars isn't really about, bold exploration in the traditional sense. It's more like a brutal, constant, minute-by-minute battle against an environment that is actively trying to kill you in multiple ways.
Yeah.
And the ways it can kill you are maybe not the ones you'd immediately think of based on our experience here on Earth. That pressure thing is a key example.
So we've taken a deep dive into the real cost, the real challenges of living on Mars, from, recycling your own sweat and urine for water, using human waste for fertilizer, to facing instant death just from the atmospheric pressure if something goes wrong for even a few seconds. It's just
Mhm.
clear that any future there is going to demand incredible resilience, amazing ingenuity, and just this constant reevaluation of what survival actually means.
Absolutely. And the insights from the source material, they're really invaluable, I think, for understanding the fundamental hurdles of space colonization. It's not just about the technology to get there. It's about how you truly exist there, day after day, under conditions that require just unprecedented levels of adaptation and resourcefulness.
Yeah. This deep dive has really shown the immense hurdles, almost unimaginable, really. And it does make you wonder, doesn't it? If a simple 5-second walk without protection is instantly fatal because of something like atmospheric pressure, what other unforeseen 5-second walks might be waiting for us, in our grandest future plans, whatever they might be? And what's it really going to take for humanity to truly prepare for those moments where there's just no margin for error at all?